Hello everyone, welcome to my channel. Continue with the series C Build for Beginner. Today we talk about static library. Here we have a simple library. The name is BitImpact. Inside it we have two C files. Each provides a simple function, say hello and say bye. And we also created two header files. Will be public so that the other programs can know what our library offers. Okay, now let's build it. First, we will compile. Success! Now we got two corresponding object files, hello.o and bye.o. Now we need to bundle these object files together to result a single output file. We'll use this command. Okay, we got the libimpact.a. This is our library binary file that we will release to the users. And why do we have to create a .a file? Why not release the .o files? Well, releasing multiple object files is actually still working, but archiving into single file .a offers several advantages. For example, this is widely known standard for distribution library. It has better organization, easier to deliver single file instead of many files. And actually the .a file has index of symbols, so the linker can find which object for each function quickly. And beside the binary itself, we should also release the header files, so that the user can easily use our library. And the release package should look like this. Okay, we release package with one static library file and two header files. Okay, it's time to use the library in our app. Here we have a simple app that includes the header files and call the functions from our library. And I placed the library package here in the same folder, but you can put it anywhere. Okay, that's it. Let's build the app. We are using GCC with familiar parameters -o to name the output file and specify the source file, that is main.c here. Then we need to let GCC knows where to look for the header files that we included in the main.c by using parameter -i. Continue with full path to the folder contains the header files. And next parameter is where the library located. Success! Now we got the output file, my app. Now we can run it. Working fine. There's a slightly different command to build it. We use parameter -l, uppercase L, to specify where to look for the library file. And then parameter -l, lowercase l, continue with the name of the library. For example, since we have the file is libimpact.a, so the parameter will be -l bitimpact. Basically, we tell GCC to look in that folder for the file name libimpact.a. Okay, build it and run. Okay, so still working fine. And that's it. That's how we use the static library. In real life, static libraries could have different format and naming convention, depends on the platform. For example, in Linux or Mac OS, it is lib then name.a, and in Windows, it's .lib file. And about the location, for system libraries, there are common locations like this. And for non-system libraries, you can put them anywhere and use GCC parameters to specify the explicit locations. So when should we use static library? Here are some practical reasons to use static library over dynamic one. Is when you want to ship a self-contained app, a single executable distribution. This makes it easier to just copy and run. And we have predictable build, exact library version locked into the binary at compile time. There will be no runtime missing dependencies error. And since it's predictable, we also have less runtime attack surfaces, security-wise. And a little bit faster startup time, as we don't have to use dynamic loader when program starts. On the other hand, there's also some disadvantages of static libraries. Like when there's many programs that share the same library, using static library with technically duplicating the library code in every program consume more storage and memory. And when a static library changed and we want to get the latest version, we also need to recompile all programs that using it. And of course, since the whole library is embedded into the app, it will make the app binary bigger, not suitable for systems where binary size is constrained. And that's about static library. Thanks for watching and see you in the next video about dynamic library.